In this lesson, we are going to introduce the rational exponent. Rational exponent means exponent is in fraction form, and all the exponent laws applied to integers could be applied to the exponents that is in fraction form. And we are going to see what the fraction, the rational exponent means. So for example, we have square root times square root. We could write it as square root bracket squared. Then square root and squared cancel out. You have 2 to the exponent 1. And 2 to the exponent 1 over 2 times 2 to the exponent 1 over 2. If the exponent laws could be applied to rational exponents, then this same base multiply, we could add the exponent. So 1 over 2 plus 1 over 2, we are going to have 2 to the exponent 1. And also, we could write this one as 2 to the exponent 1 over 2 squared from this repeat, and 2 also equals square root 2 bracket squared. So both two numbers squared equals 2, so the square root 2 equals 2 to the exponent square root 2 to the exponent 1 over 2. So both squared equals 2, then square root 2 equals 2 to the exponent 1 over 2. And by default, we know that radical sign, no numbers at front, that is 2. So in future, we are going to write, for example, if we have cubic root, third root of 8 equals 2, and also we could write it as 2 to the exponent 3 equals 8. So 2 is third root of 8. Also we could write it as 8 to the exponent 1/3. So from here we are able to see that third root of 8 equals 2, and 8 to the exponent 1/3 will be equals to 2. So this one we took 1/3 exponent to both sides. Then you have 2 equals 8 to the exponent 1/3. Then from both third root and 8 to the exponent 1/3 equals 2, we could have a conclusion that third root of 8 equals 8 to the exponent 1/3. Then in future, we are going to just move the number at front of the radical sign, the third root to the denominator, 1 over that third root. So here are the rational exponent and the radical signs conversion here. So x to the exponent 1 over n equals nth root of x. X to the exponent m over n, then the n to the nth root and m to the power. So this one, the nth root is 1 over n to the exponent. So now we are going to convert from this radical sign to the rational exponent. The reason why we want to convert it, because the rational exponent, all the exponent rules could be applied. So it will be easier for us to do the calculation or simplification. So this one, this index number goes to the denominator and the power go to the numerator. And this one, you could use your calculator to find the evaluate. And for some calculator, you are not able to type in the -8 as a base. So if the base is negative, then you need to do the numerator first, then after that, we do the denominator. So power of power is numerator times numerator, denominator times denominator. So if the base is negative, then some calculator will give you error. So we are going to do the numerator first, then do the exponent 1/3. You will have equals 4. So when you type into calculator, you could do is -8 bracket. So this one is bracket 8 negative. This is backward calculator, then bracket, and to the exponent squared first, then equals, then to the exponent again 1/3. Equals, it will give you 4. And I will try if I want to type in all the -8 to the exponent fraction 2 or 3 to see if it works. So if your calculator could just do the negative base right away, then you just type in -8 to the exponent 2 or 3. Then if it doesn't work, then you are going to do -8 to the exponent squared first, then after that do the 1/3 exponent. So the next one is negative, so we are going to convert it to the rational exponent. Then you will have, and this time be careful, the negative is not with a base, so the base is 8, and to the exponent index number to denominator and the power to the numerator. Then use your calculator, type in, you will have -4. So be careful, this one is not with a base, it's out. After you have the number, then put the negative sign front. So this one we are going to continue to do it. 27 to the exponent, power to numerator, index number to denominator. So -4/3. And when you type into your calculator, you will have fractions or decimals. We want to have a nice number, so we are going to flip the negative exponent to positive exponent, 4/3. Then we do the 27, 4/3, you will have integers, 81. So this one, 81 to the exponent, no power, it means 1. Then index number go to the denominator. Type into your calculator, you will have 3. So this is just conversion from radical sign to rational exponent. Now we are going to see why we want to convert from radical sign to rational exponent. So from this one, you have 5, the numerator exponent to numerator, and index number, no numbers at front of the radical sign. By default, its square root is over 2. Then 5 times 5 to exponent -0.5. Then the exponent rules we could apply. So we have the same base multiplications and we add the exponent. So 5 to the exponent 3 over 2 plus negative 0.5. Then you will have 5 to the exponent 1. That is 5. So that is done. And for this one is variable. So x to the exponent 3 over 2. Then x to the exponent no power, no exponent means 1. 1 over index number 3. Then multiplication, same base, we add the degrees. Then you could use your calculator or you could do the common denominator is 6, so 2, 3, both times with 3 to make the denominator 6. Then another fraction we times 2 to both numerator and the denominator to change the denominator to common denominator 6. Then after that we add the numerators together, so 9 plus 2. Then we have x to the exponent 11 over 6. So this one we could do square root twice, or you could write it as a fraction. So we do the square root, we leave the outside square root there, so 81 square root is 9. X to the exponent 8 square root is x to the exponent 8 divided by 2 is 4. Then we square root both of them. Square root 9 gives you 3. X to the exponent 4 square root. X to the exponent 4 divided by 2 is squared. So it's 3x squared. Then the next one, square root, then is third root of 32 is not integers, so we are going to convert it, use other method. So this square root we write it as 1 over 2. Then this third root is 1 over 3. Then we put the base here. Then you will see you have power of power, so it's 32 x to the exponent 7. Then power of power means times, so 1 numerator times numerator, denominator times denominator, you have 1 over 3 times 2 is 6. Then this is a product rule, so we are going to apply the exponent to each factors, so each factors of the base. So 32 degrees 1 times 1 over 6. Then x to the exponent 7, the exponent times 1 over 6. Then equals 32 to the exponent 1/6 times x to the exponent numerator 7 over 1, numerator times numerator, 7 times 1 is 7, 1 times 6 is 6, then it's that. So this is just write it in equivalent expression using exponent, convert the radical sign to exponents, and all the exponent laws we could apply to the rational exponent. So this is for converting. Then we are going to continue to practice. So this is a evaluate, use a calculator, determine each value to 3 decimal places. So if your calculator could do the negative base right away, you just type in -10, then exponent could be this symbol of x to the exponent y, then bracket -2 over 3. So we are going to see the calculator. So just type in. This is a backward calculator, so 10 and negative, then to the exponent, bracket, 2 divided by 3, then negative, then bracket, then equal sign. So it's 0.215. So 3 decimal places. The first decimal place is 4 less than 5. So round off. The answer is 0.215. Then the same thing, just type into your calculator 28 to the exponent negative 4/3. So 28 to the exponent, bracket, 4 divided by 3, then negative, bracket, give you 0.0117. The fourth digit is 7, is greater than 5, so we round up, plus 1 to the last number, the third decimal place. So 1 plus 1 is 2, so 0.012. Then we are going to continue to practice, apply the exponent laws to the rational exponent. So this one, we are going to focus on the like terms, the same base. So x with x, y with y, and the numbers, we do the simplification. So 16 divided by 4 is 4. Then x division, the exponent will be subtraction. So 4/3, take away 3/4. Then y to the exponent, 3/2, take away 3/2, or you see they are same, you could just cancel them out, is 1. Or you could do the subtraction. So we change them to the same base. It's 3 times 4. Its least common denominator is 3 times 4 is 12. So we times 4 to both numerator, denominator to the first term. Then for the second term, for the exponent, we are going to times 3 to change it to the denominator 12. And this one is y to the exponent 0. So 4 times x to the exponent, you have the same denominator 12. Then the numerator subtract 16 minus 9 give you 7. Y to the exponent 0 is 1. So that is done. Okay. And for the restrictions, because we have the variable here as a at denominator, so both couldn't be 0. So x couldn't be 0, y couldn't be 0. So that is for example 4, then example 5. So this one use a property of exponents to determine the value of the a for the equation. So this one we have the left side, we have the division, so we have the radical sign. We want to change it to rational exponent, fraction exponent. Then we could apply the exponent laws. So x to the exponent 4 divided by x to the exponent, index number to the denominator, no numbers for the exponent is 1. Then equals x to the exponent a. Then continue. The left side is division, so we subtract the exponent. Then equals x to the exponent a. And we have the same base. The power equals, then the exponent exponents should be equal. Then you will see we change this exponent equation to a regular linear equation. Then we are able to solve it. So this is a fraction subtraction. We change them to same base. So least common denominator is 3. So we change both denominator to 3 by multiplying 3 to both top and bottom for the first term. Then we have the denominator is 3. The numerator will do this adding subtracting. So 4 times 3 minus 1 give you 11. Then a value is 11. So this one we convert the exponential equation to a linear equation by change them to same base. Then you have single power, the base same, the exponent will be equal. So if the expression is written in the form a times ax to the exponent y, y to the exponent c, then what is the product of a, b, and c? So this question wants you to simplify this expression in this form. Then determine the ABC, then times ABC together. So product means multiplication times. So this is division. We are going to number, same variable, collect them, adding, subtracting the exponents for the same variable, same base. So this one we want to convert it to rational exponent, the fraction exponent. So for the numerator we have x squared, y to the exponent 4, then to the 1/4 exponent, then divided by 4 x to the exponent 7/2, then y to the exponent 7. So this is a law of product. So we apply the exponent to each factor. So the degrees, the exponents will be multiplication. So 2 times 1/4. Then y to the exponent 4 times 1/4. All over 4 times x to the exponent 7/2. Y to the exponent 7. Then we continue. This one, no numbers means it's 1, so we have 1/4 here. Then after that, we are going to see the x. So just focus. We want to write it as ax and y, so we separate them. For the number part is 1/4. And for the x is 2 times 1/4, take away, so 2/4. Then take away the denominator is subtraction, is because it's division, so it's 7/2. Then y to the exponent, subtraction, so numerator times numerator, 4 times 1 divided by 1 times 4. Then take away 7. So we simplify it, 1/4 x to the exponent. This one we could cancel common factor 2 out, so we have 1/2, subtract 7/2. Then numerator subtract when you have the same denominator. Then y to the exponent 4 divided by 4 is 1. 1 minus 7 give you -6. Then continue 1/4 to the exponent times x to the exponent. -6 divided by 2 is -3. So y to the exponent -6. Compare it with form ax to the exponent b, y to the exponent c, then you will be able to see a equals 1 over 4, y, b equals negative 3, c equals negative 6. The product of a, b, c means a times b times c. We have 1 over 4 times negative 3 then times negative 6. So numerator times numerator, denominator times denominator. For the integer, the denominator is 1. So you will have negative 3 times negative 6 is positive 18. Then divide by 4. The lowest form, both could be divided by 2 because they are even numbers. So we have 9 over 2. So this is our final answer. So in this lesson, what we have covered is how to convert a radical expression to rational exponents. Rational exponents means fraction exponent. The reason why we want to change it because all the exponent rules we could apply to the fraction of rational exponent. So it could, if it's a square root, it's a square rootable, then you just square root it right away. Otherwise, you also could write it as 81x to exponent 8. Then you have 1 over 2, 1 square root. Then also you have another square root. So then multiply these two, you will have 81x to exponent 8. Then 1 to the exponent 4. 1 times 1, 2 times 2. Now 81 to the exponent 1 over 4. Apply the exponent to each factor. So times degrees, the exponent. So then you will have 81 to exponent 1 over 4 give you 3. Then this one you times give you x squared. So either way it works. But you could always change the radical sign to fraction exponent, then go from there. And the next one we practice using calculator, and for the division of the powers with rational exponent, we are going to numbers divide by numbers, then same variable means same base. If it's division, subtract the exponent. If it's multiplication, then we add the exponent. So, and also if you have an equation that each side you could simplify to the same base, single power, then the exponent will be equal. Then we are able to convert from a rational exponential. That is not exponential, but this is the same base. Then we just let the exponent equals, and we can solve it. And also last one, we simplify, and in the a, x to exponent b, y to exponent c form, then we find a, b, c, we times them together to practice your algebraic skills. Thanks for watching.